what if one of the most powerful black holes in the entire universe was hiding in plain sight for billions of years? And we're only just now seeing it? Yeah, this thing is giving astronomers all sorts of new clues about how these monster black holes actually grow, especially way back in one of the universe's most chaotic period. So we're talking about a giant hiding in plain sight. Using the Webb telescope, astronomers have spotted this absolutely massive, super hungry black hole from a time in the universe's history they call cosmic noon. Okay, so let's get into it. Meet the big red dot. What exactly is this thing? Well, it's part of this whole new class of mysterious objects from a really wild and chaotic time in the universe. And trust me, it's got a nickname that fits it perfectly. To really get what makes Bayard so special, we've got to rewind the clock, way back. We're talking about a time called cosmic noon. Think of it like the universe's teenage years, just this super energetic, crazy period about 4 billion years after the Big Bang. Everything was happening at once. Galaxies were popping up, stars were being born like crazy, and black holes were just growing at this insane pace. And it's in this wild era that the Webb telescope is finding a whole new category of things we literally couldn't see before. Astronomers have nicknamed them little red dots, and that's pretty much what they are, these faint, mysterious little specks of light that you can only see with Webb's super powerful infrared vision. But, and this is a big but, here's the twist. The object we're focused on today, it's anything but little. It's got a supermassive black hole inside it that weighs, get this, 100 million times the mass of our own sun. Just try to wrap your head around that scale. It's staggering. So you can see why the research team was like, yeah, little red dot is not going to work for this one. I mean, with a mass that huge, it needed something a bit more appropriate, and that's how it got its nickname, BIRD, which is short for, you guessed it, big red dot. All right, so now we get to the puzzle of BIRD, because this thing isn't just huge, it's also super weird. Seriously, this discovery is a major head-scratcher for scientists, and it's making them question a lot of what they thought they knew. Okay, quick refresher. Black holes themselves, right, they don't give off any light. But when they're actively eating, sucking in all the gas and dust that's swirling around them, that material gets superheated and starts to glow with this insane brightness. And that's what we call a quasar. And you better believe BIRD is a quasar. It is shining so brightly that we can actually see it all the way from Earth. And that's mind-blowing when you realize its light has been traveling for about 10 billion years to get here. We are literally looking at a ghost from the ancient universe. How cool is that? And this is where the real mystery kicks in. Normally, a feeding black hole, a quasar, it should be glowing like crazy across the whole spectrum, especially in X-rays. But BIRD, it's just different. It's shining like a beacon in infrared light, which is why Webb could spot it. But when you look for that X-ray glow, poof, it's gone, mysteriously missing. So that leaves everyone with the same massive question. If BIRD is actively chowing down on all that material, just like a quasar should, then where in the universe are the X-rays? So how do you even start to solve a puzzle like this? Well, it all comes down to some amazing cosmic detective work. Basically, figuring out how to read a cosmic fingerprint. Here's how they did it. First step, observation. Webb's near-infrared camera spots this bright source that nobody had seen in old X-ray or radio catalogs. Step 2, analysis. The team takes a look at the object's light spectrum. That's its chemical fingerprint. Step 3, identification. And bingo, they find clear signs of hydrogen, specifically something called the Paschen gamma line, and helium. And finally, step 4, calculation. All those little details in the light let them figure out BIRD's distance and its jaw-dropping mass. And here's a great quote from Federica Loiacono, the lead researcher. She said, "I analyzed its spectrum, which tells us about the chemical composition and some of the physical properties of the object. You know, it's that kind of deep, careful work that takes a mysterious little dot of light and turns it into a real, tangible, though still very puzzling thing." So what's the best explanation for the missing X-rays? Well, the leading theory is pretty cool. It's that BIRD isn't just sitting out in the open, it's actually hidden, wrapped up in this thick cloud, like a cocoon of gas and dust. And this dusty cocoon acts like a filter. It blocks and absorbs all those high-energy X-rays, but it lets the infrared light sneak through and travel all the way across the universe to us. And this is bigger than just one weird object. Discoveries like BIRD are literally forcing us to go back and rewrite what we thought we knew about the history of the universe. So what does this all mean for us? What does BIRD teach us? Well, for one, it suggests that supermassive black holes might have these secret, hidden growth stages that we just couldn't see before. It also tells us that these little red dots were probably way more common back at cosmic noon than our old ideas predicted. And when you put it all together, it points to one amazing conclusion. The early universe was probably a much more crowded, much more complex place than we ever gave it credit for.
I mean, this just shows you what a game changer the Webb telescope is. And I love this final quote from Federica Loiacono. She says, JWST has opened a new frontier, revealing objects we didn't even suspect existed, and we're only at the beginning of this adventure. Wow, that just gives you chills, doesn't it?
So it really makes you wonder, right? If we just found this one hidden giant, what other cosmic titans are still out there, waiting in the dark for us to finally point our telescopes in the right direction and find them?